Hello and welcome back to Edge Computing World's Edge Insider. So in this series of sessions at the end of the day of Edge Computing World, we're going to be looking at the implications of what we've discussed in previous sessions, just in terms of we're thinking about what the future of the edge infrastructure development is going to be. We've heard a lot about end user thoughts about OT and IT and application management, and we also had a big focus on retail and on auto today. So, but what does this mean for us as we try and take the infrastructure of the edge forward? So, in this session, we'll be talking about holistically about the whole edge environment, and that's a lot to swallow in 45 minutes. But we're going to try and give you a quick overview, and we have some great speakers lined up for this panel for you. So. And we have some further great speakers lined up tomorrow for further deep dive Edge Insider sessions. But let's get on without any further ado. I'd like to bring up the speakers. We have Adrian Cockcroft, who's Chief Architect for AWS, Fay Arjomandi, who's the CEO of Mimik Technologies, and Jason Shepherd, who's VP Ecosystem for Zededa. And in the chair of this session is our CEO, Philippe Cass. So, and Philippe's, for those of you who don't know him, he was 25 years a VC, very successful VC, and now heads our company with its mission to educate the market around the fourth industrial revolution. So over to you, Philippe.
Yes, 30 years, Gavin. 30 years as VC. Let's get started right away. What I would like to do, and started with you, Fay, is if each of you could introduce themselves, right? Talk about who they are, and give us a little bit of your opening statement on this notion of conversion of all those ecosystems together. How do you think people should approach this convergence at this point?
All right. Thank you, Philippe, and thank you, everyone. It's a pleasure to be here. Fay Arjomandi, founder and CEO of Mimik. My background is telecom. I came from kind of 20 years of telecom experience, technology, transport layer protocol optimization over wireless. That's where I started. And for the past decade, we've been focused on hybrid edge cloud. And we focus on the notion of service mesh at the edge, and this concept of edge in versus cloud out, because we believe that the future, it belongs to heterogeneous device, heterogeneous OS, heterogeneous network, and finally the cloud, and heterogeneous business processes. So in order to start this journey of kind of a hybrid edge, we should not change the way that developers develop. We should not push them to a specific tightly coupled technology stack, but we should provide an environment that a serverless microservice, a workload, can exist on device as close to client application demand as possible, and create an information flow between them, and then go to the context of other resources based on proximity, network, and account, which we can touch on it. And we have some customers, and we are Amazon partner as well.
Awesome. Adrian, do you want to go next?
Sure. Adrian Cockcroft, I'm a VP Cloud Architecture Strategy for AWS. I've been with AWS about 4 years. Most people know me because I was the cloud architect for Netflix when we moved across to AWS. So I spent a lot of time talking to people about microservices and all kinds of stuff over the intervening time. What I've been doing at AWS was driving open source for a few years, and right now I'm starting to get more involved in things around sustainability, but generally I spend most of my time talking to customers and speaking at conferences about various topics. In this particular case, I was very happy last year to be a speaker at this event because we just really got our Outposts product out. And what we're really seeing is taking cloud from a centralized thing to a distributed thing. And we'll put AWS wherever you need it around the world. So if you need some resources in New Zealand, or you need some, in your own factory or in somewhere near your 5G cell tower. We've now got that capability, and we're doing it in a way which means that if it works, basically it's the same hardware and the same software and a very familiar developer experience, just with a subset of the services that are available. And we're working on increasing that subset over time. So that's kind of what's happening. Go into a bit more of that a bit later.
Yep. Jason, do you want to go next?
Sure. All right. Yeah. Hey, thanks for having me. So Jason Shepard, I'm VP of Ecosystem at a company called Zededa. Been working on Edge and IoT for probably about 6 years. First, of course, IoT, and then now it's fashionable to talk about Edge, and IoT, of course, is a key workload within Edge. But big believer in open, the need for open ecosystems to get to the real potential. It's ultimately about interconnecting different business cases and driving entirely new outcomes for customers. So I've been quite involved in open source for the past number of years, and then also building up commercial partnerships for IoT and Edge. Zededa as a company is very much focused on the class of compute outside of physically secure data centers, but still capable of running containerized and virtualized apps. So it's kind of driven by memory on the low end, and whether or not you're in a secure space on the upper end. And we'll get more into kind of the taxonomies as we go. But Fay, totally agree. It's all about supporting heterogeneous devices. The closer you get to the physical world, the more messy everything gets. Expecting kind of one magical standard to rule it all, not going to happen. So you have to figure out how do you bridge things, and how do you create multiple layers of abstraction across all these different elements. And like you guys said, it's provide a consistent developer experience, but it's super important to decouple how you manage and secure and orchestrate all the underlying foundations from the applications. And so that's a big focus for Zededa is how can I provide that universal open foundation that then you can go develop whatever applications you want on top and build networks where you guys would come in on top. So I think it's really important to look at it as a continuum and do many levels of abstraction.
So I mean, talking about this continuum, Adrian, is it fair to say that AWS for the time being is focused on data center enabled software or enabled location, and that you stop at the premise and you're not getting to the smarter device like cars and watch and those type of things, or
No, I think we have capabilities that reach into devices, and some of it is, we can obviously, some of it bleeds over into the Amazon retail products that are based on Alexa or Echo or whatever. There's a lot of the actual device reach and automotive is actually handled on that side of the business effectively. But we are working with, we have a big relationship right now with Volkswagen, where we've been working with them on everything from what's in the car, through the factories, through the supply chain of all of the components, and all the entire process of design through delivery and then operation of vehicles. So that's a very interesting sort of program that we announced like a year or so ago, that's been rolling out over time. But we have things like the Greengrass software, which is gives us a device at the edge, and we have some IoT, various IoT programs for different, lots of different capabilities for managing your IoT devices as well. So I think we have like a bit of everything, as most people do. But I think that the thing that's most interesting right now, I think, is just spreading the AWS regions out to local zones and through outposts all the way to wherever it's needed. So we're putting the core cloud resources much closer to the edge devices.
And when very quickly, when you have that relationship with Volkswagen, are you working with a system integrator or a big management consulting firm, or you're just taking the entire relationship together by yourself?
I'm not involved in that relationship, but I think generally we work with everybody that's involved. So we'll work,
Okay.
it's very common when we work with a customer that they have a number of systems integrators and suppliers of various kinds. And we have relationships with all the systems integrators as well as, and we have a big systems integrator ecosystem around Outposts and around our IoT products as well. Right.
And
so I think it's just all of the above, right?
Makes sense. Fay, you were saying you were a partner of AWS. So how does this partnership work? I mean, how are you working together with them?
Okay, so first of all, given our software platform is all about hybrid edge, we have our global functions that are running in cloud, and we believe that edge and cloud will always exist. In fact, it's almost like Wi-Fi to cellular, or except that telecom operator never embraced both, and they always have a disjointed experience, but between Wi-Fi and cellular. But when we focus on this continuum computing, the way we look at it is that today Amazon has a balance between abstraction layer and freedom. So for example, if they wanted to abstract too much, we would only have 2 EC2 resource, but we have so many different variation of EC2 depending on application. Similarly, on the device side, we're going to have different resource levels. So the way we see it is that edge is now new class of resource. And just like cloud, but in edge world, we have more dynamic nature. One thing that Michel Berger, our CTO, mentioned yesterday, the example between an octopus versus a bird flock, right? The way we see it is that edge is more dynamic and is more like a bird flock that these devices can dynamically discover each other and now create a communication, whether it's on a Wi-Fi without an internet behind it, because there may be situation that I don't have backbone internet, or whether it's a cellular device. Now, depending on the workload that is happening on the device side, I need to instantiate that workload. If I need to instantiate it dynamically somewhere else, I can now instantiate it on cloud, whether it's a data center that depending on the resource that I need for the task that I need. So right now, the collaboration and partnership that we have with Amazon is around, we're definitely complementary with some of the work like Greengrass and Wavelength and others. And we're jointly going to tackle some of the customer problems and use cases based on this kind of a combination solution. We're really bringing that dynamic ad hoc cluster formation of resources with a light container that allows you to run a serverless microservice, let's say on an iOS, as part of the application. And then it provides you the same API sense as Docker. So now if you're using Kubernetes for horizontal orchestration, you can still use Kubernetes. It's just that you now have enough context of what's happening at the edge that you can better do that orchestration. So use case to use case things will change, but the reality is that octopus and bird flock will meet. And it's not about one versus another, but it's about use case by use case, both will be needed. We just have to have this notion of dynamic movement of workload based on application. And workload sometimes is packaged as part of application. So we have customer today that your everyday application that you're using on mobile phone is now running serverless microservice as part of the APK. And there's no special peer-to-peer. It's just that it's faster, is better experience for customer, and you don't need to keep redeveloping serverless those piece of function in every device because of the light container that we provide that is available across all operating system, and even change the real-time operating system sensor into a smart 2-directional sensor. Yep. And it's about that ad hoc service mesh. So we're looking at a few potential customer together with different Amazon team members.
Awesome. And Jason, are you working with Amazon as well? Or I mean, describe to us a little bit your ecosystem at this point.
Yes, we've actually been working most with one of AWS's competitors. We've worked a little bit with AWS. Being that we're all about orchestration in the greater scheme of things, it's all about building an ecosystem of kind of plug-in components that solve customer challenges around our foundation. So we're working with a variety of different analytics providers, security plugins on top of our foundation, people that do data normalization at the edge, SD-WAN, things like that, a variety of things. So we're certainly agnostic to cloud. Would love to work more with AWS. We started mostly with Microsoft, but of course, it's really about building up that broader ecosystem overall. One of the things that we see, so there's all this stuff. I agree with what everyone's saying, but we see very often is like when folks have a lot of tools around data analytics, whatnot. They've got runtimes for edge, but they don't actually have a way to deliver those runtimes to the edge. We see this very, very often. And we see also, a lot of people talk about edge computing, and they talk about use cases, and they get into it, and they're doing kind of POC party of few, but then all of a sudden they have to go scale it, and they're like, man, how do I do this at scale? And it's a massive problem. And so that's something like we can run Greengrass today as an example. You run a variety of different edge stacks. That's the biggest thing that we see is that people are like, once you get past
Jason, sorry to interrupt, but we didn't hear anything. So can you repeat?
I could hear. So.
Yeah, we were able to hear. Yeah.
Okay, so I could not hear. So that was me.
Okay.
All right, so that's good.
Yeah, no. So it's
need a better
really,
edge device.
Yeah, that's right. What's funny. So I like the analogy of the birds, but and then compared to octopus, actually octopus, though I learned on Discovery, they have a brain in every arm, so they do edge computing, too. So, but anyway, so it's about building, that ecosystem, finding something that you're really good at, and doing that well. I mean, obviously AWS, you guys do a lot of different things across the board, but for us, it's how do we help people scale deployments out in the wild. The other big thing that we think is important, so of course, cloud, extending cloud native principles to the edge is key. All the things around creating a familiar developer experience, but you can't forget about all the legacy stuff out there. And so a big thing that we do, so our foundation, Eve within LF Edge is, think of it as a, kind of universal abstraction engine, kind of like an OS, but it's got an embedded hypervisor option as well. That's what our cloud service attaches to. We can support virtual machines and containers. So we can run legacy workloads right next to modern containerized workloads. Also, expanding to the kind of notion of Kubernetes and K3S. Kubernetes is a buzzword a lot of people are throwing around everywhere, but very, very important to think about how do you deploy stuff, but then also how do you support legacy, how do you secure it, and doing that really well, and being kind of agnostic to the applications on top. So, and then if you do the right abstractions, then you can kind of run workloads. And then advanced class is what I call the analytics of the analytics, where you figure out where's the right place to run workloads based on optimizations of performance versus cost. And that's going to happen over time. But right now, it's about building that foundation.
So you've been in the industry for a while. How do you compare the level of complexity you're seeing now compared to, say, 10 years ago? Is it the same level of complexity? Is it an order of magnitude?
Well, I think it's an order of magnitude. I mean, well, everything gets, the capabilities of technology sort of match, and kind of ratchet up. Like how much faster does your computer seem today than it did 10 years ago? It's just the applications, the experience gets higher and higher, and so it kind of equalizes. But in terms of supporting this distributed compute world that we're headed into, and it's going to be very, very diverse, which is why we're all talking about this need for flexibility. I think it's increasingly complex, and I think gone are the days of a lot of the silos that we've seen. I think that this need for open interactions between different use cases is where the real business opportunity is. Kind of interconnected ecosystems that creates more complexity, but it also creates more opportunities. So it's key to kind of embrace that model, I think, as we go forward.
Well, Adrian, would you agree with the notion of interconnected ecosystem as the way to move forward? Or?
I think, everything's interconnected, but I think we're at a point now where there's some really interesting inflections happening. I don't know how many people watched the Apple launch video yesterday for the iPhone 12 with 5G. There's quite a lot of things there. Firstly, the performance of the CPU in there, it's probably, if you have one in your pocket, you've probably got the fastest CPU in the building, or in, it's a ridiculously powerful chip. It's got, I don't know how many teraflops of performance or whatever. So you've got this incredibly powerful AI engine in your pocket. It's got LiDAR, it's got a high bandwidth network. So I think, and finally, the biggest phone manufacturer now has a full product line of 5G. So I think this is the point where 5G starts to become real for people. And then they also had Verizon on stage showing what you can do with this. And one of the examples, one of my favorite examples, is they showed a stadium. So Verizon has rolled out 5G to a bunch of stadiums because you get what is like 1 million devices per square kilometer instead of 100,000 or whatever the number is. But they can actually support a whole stadium with the full bandwidth. And this is one of the places, we're working with Verizon. The technology you put in that stadium would be an outpost rack with wavelength, and you can work with the NFL to automate the game, so you can see, what the players seeing as they run down the field, and you get virtual reality headsets, and you're at the stadium. So it becomes a destination thing, obviously, maybe post-COVID, but once we finally get back to it, so maybe we all remotely access the stadium with a bit more latency from home, but it's going to be much more visceral, low latency in the stadium once we get all these things going, and it's going to drag people back into that experience. So I think there was some really interesting sort of possibilities there, and the idea that the power that we've got in the center is now moving to the edge. This is sort of slightly different to just the edge devices, which are generally much lower power. But the performance, a lot of our customers for our outposts are taking GPUs and putting them in these racks at the edge. Games companies are one of the big use cases. They want low latency for all the interactive games. So they're using outposts to deliver capacity to wherever their pockets of actual end users are. So I think that's a sort of an inflection point for how much capacity, latency, and bandwidth there is to customers. And then there's a whole other discussion around devices, and obviously cars and static devices and factories, which is, I think, I'm less of my area in terms of what I'm familiar with, but obviously there's a lot happening in that space as well.
Hey, Jason, so stadium is the example that Adrian is bringing. What is your use case, the favorite use case that you have built on Zededa right now?
Yeah, so we're doing stuff like, putting compute out in wind turbines to do predictive maintenance. You leveraging audio signals within the cowls. We've got compute, on factory floors to segment out the OT processes from pulling that data up into the cloud, run some local apps. Anything around computer vision is a killer app for Edge today. Anything involving video. Only folks that sell you connectivity think it's a good idea to send streaming video over the internet. So you want to run that locally. And I think it's, just building on Adrian's comments. So obviously the Edge is a continuum. Speaking of computer vision or just kind of connectivity in general, is a lot of people use Edge broadly speaking. Very important to realize in terms of latency. So latency is a very overused term. Real time is a very overused term. Real time to a building is like 15 minutes. Real time to an airbag, a little shorter. But basically, very important in terms of technical trade-offs. So as much as we talk about abstraction, you want to be able to have a consistent experience developing. You've got to understand that latency critical is very different than latency sensitive. Latency critical, safety issue happens, someone dies, airbag, whatever. You will always run that on a local area network. Latency sensitive, wide area network. I mean, the stadiums are great examples. Like, you could drive the stadium with outposts, there, running, really, really cut down on latency. No one's going to die if the game shuts off. But you can do all kinds of incredible stuff. But it's just really thinking through, the implications of latency sensitive versus latency critical, And then also when compute is not in a physically secure data center, very different in terms of how you secure it. So that's a big part of our focus. So, use cases, they're across the spectrum, but, I think it's important to kind of think about some of these trade-offs when you get into it, because otherwise it just sounds like, any given solution could address anything. And there's similar principles, but necessarily different paradigms.
Yeah, that makes sense. And Fay, what about you? What is your favorite use case for the time being?
Well, I'm going to use the same examples that our colleagues used. For example, in the wind turbine, right? Yep. So I have compute in the wind turbine. I'm calculating some information, but then the field technician walks in and need to access that information. Again, that ad hoc cluster formation that now I need to fetch data, or I need to get a view of data to the data that wind turbine is creating, right? And yep. and totally agreed. I mean, I come from Vodafone background, so we are Vodafone Telecom. They love to put SIM card in everything, which is not really practical. And our chairman is Siavash Alamuti, who's the inventor of Alamuti code that is in every cellular and Wi-Fi device. So to us, again, it's about that ad hoc communication. I gave one example today about a bulldozer, an electronic shovel at the mine. The sensor is attached to the electronic shovel, and the operator needs to see that data. That the operator of the machine, the sensor can send that information to that machine operator display directly versus going through gateway, through public, through private data center. And you can put policy into that sensor as well, that, hey, if you detecting a heat more than this, now send that data to another field technician, or send that data to this address, which is another bulldozer, to start working. So going back at the end of the day, it's about eventually optimized systems, right? And at the end of the day, it's about defining, enabling, like when we talk about microservice development and legacy, one of the good things that is happening is that microservice development itself is pretty new thing. So when companies talk about cloud 2.0 transformation, they're talking about moving from a legacy monolithic to cloud to microservice architecture. And that becomes the perfect time to start developing your client agent and application right from the device with microservices, whether it's even front-end function or back-end function that can now coexist on the same device. Provide ability for those serverless microservices to be deployed dynamically or statically as part of the application. It's open, could be Open Horizon, it could be Kubernetes, it could be Zededa, application management. These are different layers. And the other thing that we have to ensure we don't do, which operators again are famous for doing that, is to try to define every layers of a framework. Which we see over and over, like IMS failed, the SDP service delivery platform failed. All these efforts to tightly couple developers with one framework, especially in an environment that we don't know what we don't know. Like when we talk about digital transformation, we really don't know how things are going to evolve. So you need to create a model that app developers can continue their agile app development, RESTful API first approach, that if I am now to communicate with another application, all I do is that I expose my API on another to another device. Obviously, you have proper layer of security in your platform, but you still allow your app developers to also add the level of security that they see needed for their application and for their business use cases. So we have use cases in a smart mobility, for example, that you can train a model in cloud. You can push the model to the car. The camera can utilize the model, and based on certain obstacle can inform other car within proximity as part of, okay, now I need LTE, but it also informed the passenger and the driver through a POS to onboard computer of the on the car to the infotainment, two boards. but they're communicating via pure Wi-Fi, for example. So then you propagate the knowledge to the proximity, to the cars around you. Then you are able to make quick decisions based on that cluster of proximity in that kind of a semi-hyper local fashion, and you send global knowledge to the rest, right? And you propagate that information proximity cluster by proximity cluster as well. So to me, there are millions of use cases. We're doing ourselves as an industry, the service, if we try to focus on complexity and if we try to focus on use cases that are defined for the edge versus looking at how can I use what I have today while I'm consuming and or taking advantage of my edge device power of compute. As Adrian said, iPhone now is one of the most powerful edge computer on your hand. All we do is take a selfie with it and publish it on the cloud. We could utilize applications that are now, we could utilize it for applications that are simply can use that power of compute, do the data processing on device. And the reason you do that is for reducing your cost of operation, reducing your latency of communication, improving data privacy. One of the things that is happening today is data exploitation. We're all getting manipulated. Our data is going everywhere and we're not seeing anything in return of it. So for more data privacy, when we talk about GDPR, it's about data processing on device. And the best systems, I mean, just look at internet around us. It's one of the most complex systems, but is loosely coupled, right? And the best system are loosely coupled. And the communication infrastructure should be basically based on simple verbs which are defined in API. So this is where how we look at the world, and totally agree with Jason as well that with respect to analytics, you also when you have edge, you provide login mechanism that can generate report right on that Android device, right on that iPhone, based on the visibility that it has. Again, propagate the analytics to the local cluster and propagate the knowledge to the higher, basically global function.
And so if quick question for you, Jason, if you're thinking about the type of application that you're working on right now, are there fundamentally new application enabling new thing, or is it rewrite of existing application?
I mean, it depends. I mean, we see a lot of people that have existing applications that are running in Windows or otherwise. Why does it make sense to rewrite it if they can just kind of shift it over? If it's like a legacy SCADA system, point of sale, whatever. But there are, to some degree, rewrites required based on the capabilities of the device. But in a perfect world, if you can build models that and also there's tools to be able to build more compact models, maybe you lose a little performance, whatnot, but you want to invest in things as much as possible where you can make everything transportable, as we're saying. So I think that it's a mix of necessarily new development, using existing tools, but just having the right infrastructure that allows you to run them as is, next to more modern development, and then kind of tailored stuff. But I think in all cases, so I agree. Like it's we got to get away from just like, well, there's people looking at edge as like this myopic thing. Everything is going to run at the edge. The cloud's going away. There's a bunch of clickbait about that. Not going to happen. Any edge application has good edge application going forward has the cloud in mind of how they work together. You need to architect for how you distribute workloads, but then just run the workload where it makes the most sense based on trade-offs. I do think it's very important to have a multi-cloud strategy that starts with an open edge. You mentioned the internet, Fay. Like, imagine if a couple companies own the internet. It doesn't work out so well. You must have your data decoupled from any given backend the moment it's created. Now all permutations between an edge and cloud work. And so that's why it's super important to abstract all that lower level capabilities around security and orchestration management, data integration, kind of data normalization. And then there's great services the clouds are offering, all the stuff that you guys are doing on your side, Fay, and whatnot. I mean, there's you just have to plan for it. Plan for that, the inevitable. I get asked all the time, where should I run my workloads? The answer is, you're not going to know. You have to just plan for it being anywhere.
Mm-hmm. I mean, that's one of the areas that, generally speaking, I think the market is losing sight that whenever you want to develop an application, you have to start with system architecture. And you have to start with defining your RESTful API first, and then develop a bunch of microservices that describes that. So I hear you. I mean, that's one of the challenges in the market. But I want to point out one thing. I mean, legacy systems and trying to protect the legacy system. And I want to be careful with what I'm saying, because I'm not all about, hey, let's yank everything that you have and throw it out the window and let's start from scratch. In fact, I think Edge is allowing that transformation in a much more elegant, rapid, and agile format. Maybe I have PTSD, but coming from telcos, I think legacy is what prevented them from really moving forward. They tried to protect the SMS as legacy, but then WhatsApp came and everything went away. That's just simple example. Even voice, they hardly use voice anymore. I can make my a call via my FaceTime audio with much better quality than millions of dollars that is spent in putting 4G quality of service for voice. And I live in Bay Area in the heart of technology sector. So we have to be practical and pragmatic. And again, that's what we're saying, that it's about everything. Again, going back to octopus, our famous octopus and bird flock, the tentacles need to talk to each other versus everything connect to a head. So that's where we think that everything will talk to everything. I have a 5G phone, great, but when I'm coming home, I have Wi-Fi. And my devices, although they're not the same operating system, need to be able to exchange information. Or when the field technician walks into an industrial IoT, industrial manufacturing, they need to be able to connect and receive information. So that is what will help all of us to really get the adoption going. And try to make it as simple as possible. And the business processes, I mean, 20% of industry have gone through their cloud journey according to Gartner. 80% are just starting. So there's a massive non-digital businesses that need to get digitized, and they don't have legacy. Those are all good things for all of us.
Yeah. And question, Adrian, I wanted to talk about ROI, right? So we've talked about new features, new functionalities. I mean, is ROI still kind of the judge of peace for those type of implementation? Are people looking at the return on investment? And how can people look at the return on investment for an Edge application?
I think generally what people are doing, they've got so much old legacy that just gets more expensive. I mean, so some of it is just obsolete and it's coming to end of life. We've seen sort of 2G networks go away and things like that, forcing upgrades. There's security problems in old systems that aren't upgradable. So some of it is forced upgrades, and that's not a cost thing. It's just you have to do it. And generally, I think what we've been able to do is build with cloud. You just pay for what you use. So the important thing is to build elastic. This is part of the cloud native idea, right? Your application should be elastic. It should grow and shrink, and it should be, if you've got something that's monitoring parking spaces, then there's nobody parked there most of the time, and then it's certain times of the day it's really busy, right? If it's one of those street lamp monitoring systems or something. So there are things which are very cyclic. So you want to be able to scale up and down based on the traffic, and the ability to share the infrastructure behind it and have the multi-tenancy is really what gets you to a high efficiency. And then just the efficiency with which the cloud providers run their systems means you're running at a much higher utilization, much higher efficiency system. I wanted to bring up another sort of customer example that's quite relevant nowadays. A lot of us are sort of worried about hospitals and the need to go to them nowadays. And there's a lot of ancient technology in hospitals. They've ended up a long way behind the curve. And we've been working with Philips Healthcare as a whole, a huge rollout. They were one of our first customers for Outposts, where they're basically going through hospitals and rebuilding the back-end technology that runs at the edge in the hospital. And obviously there's life-critical systems, there's very private data, and then there's a huge number of devices that need to be connected in. So it's one of those classic environments which is, it's not quite like a shop floor, because everything, there's consumers coming in and out, or patients coming in and out, but there's a lot going on there in delivering the next generation of healthcare environments out to hospitals. And like I said, they were really one of our first partners for Outposts and helped us define what we needed. And the way AWS works is we find customers like Verizon and Philips and say, okay, what did you actually need? And then we go and build that and roll that out. And we're very much driven. So if there's particular things that you see you need, AWS is always listening for what can we do next? What are the next features we need? What are the next products we need? We have things like a Snowball, which is a storage, a ruggedized storage product. And people said, well, it's a bit big. It weighs 50 pounds. Can you do a smaller one? So we did a sort of a shoebox sized one that you can stick in the back of a car, and it mails itself around, but it's a much smaller, more portable device. And that we brought out with recently. So these are sort of the drivers that makes AWS pay attention to some of the most forward-thinking customers about where are they trying to take everybody.
Yeah, makes sense. So we have 3 minutes remaining. So why don't you take each 1 minute to talk about something we didn't talk about that you think is important? Fay, do you want to start?
I think I would say that a few things. I mean, there are a lot of things that we can talk about, but take a solution architecture first approach. Take an API first approach. Microservice driven architecture. Don't try to be too clever about, hey, I need a use case that I force fit this kind of a technology into it, but really look at practical use cases. Edge is disruption, and use it to modernize and use it to build new systems. Modernizing edge up is the best opportunity. Example of healthcare, bedside patient monitoring. You need to send information to a physician on the same floor. I don't need 5G. I can just send data from one bedside patient monitoring to the physician tablet. And by the way, I don't even need to move the data. I can provide a view to that data on that same bedside patient monitoring device, because if the doctor leave the hospital, they don't need to carry that data with them outside. So there are so many advantages and so many new use cases that we can build and utilize edge as a disruption and use it for modernization.
Awesome. Jason?
Yeah, so I think so. We talk about the importance of architecture and various use cases. To make any of this happen, especially this notion of interconnecting ecosystems, all the different stuff, talking to each other, the next major conversation that has to happen, and you look at all the deep fakes, et cetera, is about trust. So you're seeing a lot of people start talking about trust this year. An area why do I think openness is so important? Because you need transparency to build trust. Open source is the best way to drive standards these days. It's the modern way to drive standards. When I say trust, something I've been working on with a variety of folks is this notion of trust fabrics, where I take a variety of different technologies, not just blockchain, distributed ledger, but root of trust down to silicon, immutable storage, open API frameworks, and you combine, S to ledger, you combine these things together in a de facto standard way, and you can start to deliver data across heterogeneous systems with measurable confidence. And so, that's a lot to say in just a couple minutes, but like the whole notion of trust across heterogeneous systems to really make any of this work is going to be a major conversation going forward.
Awesome. Adrian?
Yeah, actually, I can segue off that pretty well. I wanted to talk about the security model that we have in Outpost, because I think it's quite interesting. There's tamper-proof. It's, there's obviously a rack with a lockable door, but that's pretty standard. But all the data is encrypted. This is standard on all AWS machines. We actually, in some of our machines now, we encrypt main memory. And the way you recycle a machine for somebody else to use it is you delete the key. You don't wipe the memory, you delete the key. Then now the disks and the memory contain just random numbers. You just have to delete the key, right? So the way it works in Outpost is every machine has a hardware security key. In order to take the machine out of the rack, you have to take that key out. And then the encryption key is in the piece you just took out. And then there's a thumb screw on that key. You can screw it up and it physically destroys the chip in the little dongle that holds the device into the rack. So if you need to return a machine for, say a machine fails for some reason, you need to return it for service, you can actually be sure that all the data on that machine is completely wiped before you put it in a box and ship it back to us, for exchange. So this is, obviously network encryption and things, but this sort of tamper-proof idea that the trust model that we have in the cloud goes all the way down to the machines that we have, even though we don't have physical access. We've done everything we can to give you a highly secure tamper-proof environment for the hardware and the storage you have locally.
Great. Thank you so much for those parting thoughts. I mean, it's great because it gives us an idea of where the world is going. So thank you so much, Fay, Adrian, and Jason. We are all available tomorrow. So if you want to talk to us, do not hesitate to reach out through the Swapcard platform. And I think we have also a get together now. So, looking forward to seeing you there. Thank you so much.
Thank you.
All right, thank you.
Thank you. Pleasure. Bye.
Bye.